Similarly, we could do in plane and through plane in the pulmonary area. So for example, in a pulmonary in the pulmonary area in plane, so if from the acquisition of the localizer or the haste, which sometimes we do it as an axial cuts to see the lungs. So if it is just through the pulmonary artery and the pulmonary area, this could provide you with this view, which is the right ventricle, RVOT, pulmonary valve, and the pulmonary artery. And a line passing through the right ventricular outflow tract, pulmonary valve, this would provide you with another view as a coronal view for the pulmonary area. And again, similar to what we said about the left ventricular outflow tract, you could have an idea about the left, the right, the pulmonary valves, whether thickened or not, any kind of stenosis, and we have learned how to measure the Vmax. Through plane, using those two views, the RVOT and the coronal RVOT, so you could easily obtain an end-on appearance of the pulmonary artery, and if you do it as a flow sequence, then you would be able to contour it in the software, and then you would be able to see whether there is any kind of regurgitation or not. As you may see, this white or bright signal means that this is the systolic flow, but here this dark signal, this is diastole now, and it should be that the software not detecting any flow. But if there is a backward flow here represented by this dark signal, this is a kind of the regurgitation amount. Tricuspid is similar to the mitral, so at that time RV stroke volume minus left ventricular stroke volume could provide you with the amount of the tricuspid regurgitation.